Hello, dear students. My name is Alim. Today we will study trigonometry, and our today's topic is verifying trigonometric identities. In previous lesson, you have studied how to simplify trigonometric expressions, but in this lesson we will learn how to verify trigonometric identities. For this, firstly, we need to know some basic trigonometric identities. That first basic trigonometric identity is tangent x is equal to sine x over cosine x. Another basic trigonometric identity is cotangent x is equal to cosine x over sine x. Third basic trigonometric identity that we will use in this lesson is sine square x plus cosine square x is equal to 1. Next identity is second x is equal to 1 over cosine x. And last identity is cosecant x is equal to 1 over sine x. In this lesson, we will use these basic identities to verify trigonometric identities. In this lesson, we will have more complex trigonometric identities, and we will verify, or we will prove these identities. First identity or example is like this. Tangent x multiplied by cosine x is equal to sine x. Shortly, we need to show that this expression is equal to this one. We need to show, or we need to prove or check. Firstly, instead of tangent x, we can put this expression by using first basic identity. Instead of tangent x, we can write sine x over cosine x multiplied by cosine x is equal to, here we make cancellation, and here we get, on the left side, we get sine x. So this expression is equal to sine x. So we have verified it. We have verified this trigonometric identity. Second example, let's verify next identity. Tangent x plus cotangent x is multiplied by cosine x, and this is equal to cosecant x. We need to show that this expression is equal to cosecant x. Firstly, tangent x we can change to sine x over cosine x plus, instead of cotangent x, we can write cosine x over sine x. And this is multiplied by cosine x. To add two rational expressions, we need to have equal same denominators, so we need to equalize denominators like this. Here I will multiply by sine x, and here I will multiply by cosine x. Sine x will be multiplied by this one and this one too. So on upside, I will get sine square x, and denominator will be cosine x multiplied by sine x, and here I will get cosine square x, and downside will be cosine x multiplied by sine x, and this will be multiplied by cosine x. So now I have equal denominators, and I can easily add numerators like sine square x plus cosine square x. And the denominator is cosine x multiplied by sine x, and this is multiplied again by cosine x. By using third identity, what do you think this expression is equal to? What? Or what is equal to this expression? Instead of this expression, I can write 1, because sine squared x plus cosine squared x is equal to 1. So 1 over cosine x multiplied by sine x multiplied by cosine x. I will continue here. Here I have one cancellation, cosine by cosine. In the end, I will get 1 over sine x, which is equal to, from last identity, that which is equal to cosecant x. So we have verified this identity too. Next example is more difficult than this one. Let's verify next identity. Cosecant x over cosine x plus cotangent x is equal to secant x. So let's go 1 plus, instead of cosecant x, we can write 1 over sine x over, instead of cosine x, we cannot write anything, so without any change, I write here cosine x, and instead of cotangent x, I can write cosine x over sine x. Then, how can we continue? Instead of 1, I can write 1 over 1. To equalize denominators, I multiply by sine x, and here by 1. Cosine x, same expression with cosine x over 1. Or instead of cosine x, I can write cosine x over 1. Here I multiply by sine x, and here I multiply by 1. Upside of this big expression, on the upside, I will get sine x over sine x plus 1 over sine x. Downside, here I get cosine x times sine x over sine x added to cosine x over sine x without any change. And here I got here equal denominators here too. So I can easily add now upper numerators like sine x plus 1, and denominator will be sine x, and here I get cosine x times sine x. I hope you can understand what I write now, plus cosine x over sine x is equal to, here I can make cancellation like this, sine x by sine x, and in the end I will get expression like this, sine x plus 1 over cosine x times sine x plus cosine x is equal to sine x plus 1. What do you think? Which expression I can take out of bracket, or in this expression in denominator, which value or which expression is common factor? Common factor is cosine x. So I can take out of bracket like cosine x. Inside of bracket we leave sine x plus 1, which can be cancelled with numerator like this. And in the end we get 1 over cosine x, that is equal to secant x. And this trigonometric identity is verified too. Example number 4. This is the last example of this lesson. Let's go. 2 plus, instead of tangent x, what can we write? Tangent x is squared. That's why we can change form of this is expression like tangent x over and secant x like this minus 1 is equal to, must be equal to cosine square x. We'll verify later. So 2 plus, instead of tangent x, now I can write sine x over cosine x with a square. Instead of secant x, I can write 1 over cosine x. This is squared 2 minus 1. If we will open bracket, we will open like this, sine square x. This will be cosine square x over 1. Okay, square over cosine square x minus 1. Firstly, 2 must be added to this one. That's why 2 I will write like this, 2 over 1. And left part I will multiply by cosine square x, and this part I will multiply by 1. And I will get new form like this, 2 cosine square x over cosine square x added to this part. I will not change. I will write without any change sine square x and cosine square x. Here I will write 1 over cosine square x. In this part I have equal denominators, so I will add numerators like this. I'm sorry, I have forgotten minus 1. Here I can add like 2 cosine square x plus sine square x over cosine square x, 1 over cosine square x minus 1. We have cancellation here. Cosine square x can be cancelled by cosine square x, and after cancellation, after simplifying, we will get expression like this, 2 cosine square x plus sine square x over 1 minus 1. And if we will continue, let's continue, 2 cosine square x plus sine square x minus 1. Dear students, what can I write instead of sine square x? Look at this. By using basic identity sine square x plus cosine square x is equal to 1. If we will move cosine square x to right side, on the left side we will get 2 square x, and on the right side we will get 1 minus cosine square x. So instead of sine square x, I can write 1 minus cosine square x. So 2 cosine square x. Instead of this part, I can write 1 minus cosine square x minus 1. And here plus and minus, here we get 0, and 2 cosine square x minus cosine square x. In the end, we will get just cosine square x. So this trigonometric identity is verified too. See you in next lesson. Goodbye, everybody.